6 hours. That's how long 20% of the internet went dark when Cloudflare accidentally deleted their own customers' networks.
Wait, they deleted customer networks? How does that even happen? So we're breaking down the config bug, why their safeguards failed, and what manual processes are still lurking in your stack.
By minute 4, you'll know exactly which cleanup tasks to audit immediately. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into Cloudflare's outage on February 20th, 2026.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about what happened with Cloudflare on February 20th. This wasn't just another CDN hiccup. This was a 6-hour outage that exposed some fundamental challenges in how we manage IP address ownership at scale.
6 hours is an eternity in internet time. What exactly went wrong?
They had about 1,100 BYOIP prefixes, that's bring your own IP prefixes, completely withdrawn from the internet. These weren't small customers either. We're talking about enterprises who brought their own IP address blocks to Cloudflare's network.
Wait, help me understand BYOIP better. Why would companies want to bring their own IP addresses to a CDN?
Great question. Think about it from an enterprise perspective. You've spent years building reputation on specific IP ranges. Maybe you've got whitelisting agreements, compliance requirements, or just brand recognition tied to those addresses. When you move to a CDN, you don't want to lose all that equity.
So these companies trusted Cloudflare with their most critical asset, their internet presence.
Exactly. And for 6 hours, 25% of all BYOIP customers basically disappeared from the internet. No malicious attack, no hardware failure, just a configuration change that cascaded into a nightmare.
How does a configuration change cause that level of damage?
That's where this gets really interesting from a platform engineering perspective. They were making changes to how their network manages IP addresses in the BYOIP pipeline. Sounds routine, right? But here's the thing. When you're operating at Cloudflare scale, there's no such thing as a routine change.
I'm seeing parallels to issues we've dealt with in our own infrastructure. The bigger you get, the more your blast radius expands.
And that's exactly what platform engineers need to understand here. This wasn't about bad code or incompetent engineers. This was about the inherent complexity of managing global infrastructure where a single configuration propagates across hundreds of points of presence.
The timing is interesting too. 1748 UTC. That's peak business hours for European customers.
Right, and here's what's particularly painful. The affected customers couldn't even fail over to another provider quickly because these were their own IP addresses. You can't just flip a switch and move your IP blocks to AWS or Akamai. Those addresses are locked into Cloudflare's BGP announcements.
Oh, that's a critical point. This is different from a typical CDN outage where you might have DNS-based failover options.
Exactly. And it gets worse. The withdrawal happened iteratively, not all at once. So some customers were watching their peers go down, wondering if they were next. Can you imagine being in that operations room?
The psychological impact alone, knowing you might be next but having no control?
What really struck me was their incident response. They detected the issue pretty quickly, within 8 minutes of the first withdrawals. But detection and remediation are two very different things when you're dealing with BGP.
BGP convergence times are notoriously slow. Even after you fix the config, it takes time for the internet to learn the routes again.
And that's just the technical side. The real platform engineering lesson here is about the human systems that failed. How did a change that could affect 4,306 BYOIP prefixes get deployed without catching this risk?
Coming up, we need to dig into exactly what their change management process looked like and why their safeguards didn't catch this.
So let's dissect what actually happened, technically. Cloudflare made a change to their BYOIP pipeline, specifically how IP addresses get onboarded and managed. This wasn't a BGP configuration change directly, but a change to the system that generates BGP configurations.
That's a crucial distinction. They weren't touching the routers directly, right?
No, and that's what makes this so insidious. They were modifying the control plane, the system that tells the routers what to advertise. When that system started generating incorrect configurations, it essentially told their edge routers to stop advertising customer prefixes.
So the routers were doing exactly what they were told to do. The instructions were just catastrophically wrong.
Right. And here's where the numbers get scary. They have 6,500 total prefixes advertised to peers. 4,306 of those are BYOIP prefixes. When the bad configuration started propagating, it withdrew 1,100 prefixes before they could stop it.
How does a quarter of your BYOIP infrastructure disappear before someone notices?
That's the thing. They did notice quickly. 8 minutes from first impact to detection. But in BGP time, 8 minutes is long enough for the entire internet to reconverge around the belief that those routes don't exist anymore.
And then you have the path hunting problem.
Exactly. BGP path hunting is this phenomenon where routers keep trying to find alternative paths to unreachable destinations. Every router that learned about the withdrawals starts looking for another way to reach those IPs. This creates massive churn in routing tables globally.
What about their rollback procedure? Why did it take 6 hours?
This is where it gets really interesting from a platform engineering perspective. They actually had 3 different categories of impact. First, some customers could self-remediate through the dashboard, just re-advertise their prefixes. That's good design, giving customers that control.
But that only worked for some customers.
Right. The second category had their configurations corrupted in a way that the dashboard couldn't fix. These needed manual intervention from Cloudflare engineers. But the third category, about 300 prefixes, had their service configurations completely removed from the edge.
Removed? Not just disabled or withdrawn?
Completely gone. The software bug didn't just withdraw the advertisements, it deleted the configuration state. Those had to be manually reconstructed, which is why the last prefixes weren't restored until 2303 UTC.
That's a 5-hour recovery window for some customers. In terms of SLA impact,
Let's talk real numbers. If you're running a 99.99% uptime SLA, you get 52 minutes of downtime per year. This single incident blew through that for affected customers. And these are enterprise customers paying significant money for BYOIP services.
what about the cascading effects? 1.1.1.1 was showing 403 errors.
That's because 1.1.1.1 itself uses BYOIP prefixes. When those got withdrawn, the service became unreachable. But here's the irony. People probably tried to use other DNS resolvers to check if Cloudflare was down, not realizing that the DNS service itself was a victim.
This feels like a canary in the coal mine situation. Did they not have monitoring on their own critical services?
They did detect it quickly, but detection doesn't equal prevention. The real question is, why didn't they have circuit breakers? Why could a configuration change affect 1,100 prefixes without hitting some kind of limit?
That's the platform engineering failure here. Not the bug itself, but the lack of blast radius control.
And let's talk testing. How do you test BGP withdrawals at scale? You can't exactly simulate the entire internet in your staging environment. This is where platform engineering hits the limits of traditional testing methodologies.
You need progressive rollouts, canary deployments for configuration changes.
Exactly. But even that has challenges. BGP is stateful and global. A configuration that works fine for 10 prefixes might cause unexpected interactions at 1,000 prefixes. The nonlinear scaling effects are brutal.
Stick around. We'll break down exactly what platform teams should take away from this incident.
So, what should platform engineers take away from this incident? First and foremost, configuration changes are code. They need the same rigor, testing, and rollout procedures as any software deployment.
But how do you actually implement that for something like BGP configurations?
Start with treating your network configuration as infrastructure as code. Version control everything. But more importantly, implement semantic validation. It's not enough to check if the syntax is correct. You need to validate the intent.
So in Cloudflare's case, a validator that says, hey, you're about to withdraw 1,100 prefixes, are you sure?
Exactly. Build circuit breakers into your configuration management. If a change affects more than X% of your infrastructure, it should require additional approval or automatically halt.
That's a great framework. What else?
Second takeaway, invest in rollback capabilities that actually work. Cloudflare could revert the change, but the damage was already done. Your rollback needs to be faster than your failure propagation.
That's challenging with BGP, though. The protocol itself has built-in delays.
Which brings us to the third takeaway. Understand your protocol's failure modes. BGP withdrawal is fast, but re-advertisement is slow. Your incident response needs to account for these asymmetries.
What about the customers who could self-remediate through the dashboard?
That's actually a bright spot in the story. Giving customers emergency controls over their own infrastructure is good platform design. If you're building platform services, ask yourself, what controls can I give users to fix problems themselves?
But that only works if the platform itself is available, if the dashboard had been hosted on BYOIP addresses.
Exactly. Fourth takeaway, your control plane must be on different infrastructure than your data plane. Never put your recovery tools on the same infrastructure they're meant to recover.
This also highlights the importance of dependency mapping, understanding what services depend on what infrastructure.
Fifth takeaway, practice your incident response with this scale in mind. Cloudflare published customer guidance at 1919 UTC. That's 90 minutes after the incident started. In a crisis, can you communicate with thousands of affected customers quickly?
And not just communicate, but give them actionable steps.
Right. Your runbooks need to include customer executable recovery procedures. Don't just document what your team should do. Document what customers can do to help themselves.
What about the broader industry implications?
This incident reinforces why multi-CDN strategies matter. Yes, BYOIP makes it harder to fail over, but not impossible. You can advertise the same prefixes from multiple providers if you architect it correctly.
That's a complex setup, though.
It is, but that's the trade-off. You want the benefits of BYOIP, you need to invest in the redundancy to match. Platform engineering is all about understanding these trade-offs and making informed decisions.
Any predictions for how this might change the industry?
I think we'll see more investment in configuration validation and testing tools. The market for network configuration testing is about to get a lot more interesting. We might also see new BGP extensions focused on safer advertisement changes.
Like what?
Imagine a staged withdrawal capability, where you could slowly reduce the preference for routes before withdrawing them entirely, or better coordination protocols between providers for BYOIP failover scenarios.
That would require industry cooperation, though.
True, but incidents like this tend to catalyze cooperation. Nobody wants to be the next 6-hour outage story.
So if I'm a platform engineer watching this, what's my immediate action item?
Audit your configuration change processes. Look for anywhere you're making changes that could affect multiple customers or services. Ask yourself, what would stop this change from taking down 25% of my infrastructure? If the answer is nothing, you've got work to do.
And remember, it's not about preventing all failures.
It's about limiting the blast radius when they happen, because they will happen. The question is, will it be a 6-hour global outage or a 5-minute blip that only affects a small subset of users? That's the difference platform engineering makes. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating discussion happening on Reddit's sysadmin community about real-world AI use cases that are actually delivering value. Platform engineers are sharing some surprisingly practical applications, from automated ticket routing to log analysis and even infrastructure documentation generation.
What caught my eye was how many teams are using AI for mundane but time-consuming tasks. One engineer mentioned using it to parse through security logs and flag anomalies that would have taken hours to spot manually.
Exactly. And several folks pointed out that the biggest wins aren't the flashy chatbots. It's the behind-the-scenes automation that's freeing up engineering time for more strategic work.
Speaking of AI productivity, the new Stack published an interesting piece arguing that we're missing a critical piece of infrastructure to really capitalize on AI's potential.
They're calling out the lack of robust, continuous delivery pipelines as the major bottleneck. While AI can help developers write code faster, most organizations don't have the CD infrastructure to actually ship that code efficiently.
It's a classic platform engineering problem, right? You can accelerate development all you want, but if your deployment pipeline can't keep up, you're just creating a bigger traffic jam.
The article suggests that without proper CD practices, AI-generated code just piles up in staging environments, never making it to production where it can actually deliver value.
Now for something completely different. There's a detailed guide on getting HTTP3 and quick working with nginx in FreeBSD Bastille jails.
This is from Hofstede.it, and it's a deep technical dive into the configuration challenges. The author walks through SSL library compatibility issues and worker process affinity problems that platform engineers might encounter.
What's interesting is how they solve the UDP port forwarding issues specific to jail environments. It's not straightforward. You need specific firewall rules and nginx configurations to make quick work properly in containerized FreeBSD.
For teams running FreeBSD infrastructure, this could be a game changer for improving web performance with HTTP3's reduced latency benefits. That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.